When both equations we are trying to solve are in the general form like these two are, the substitution method solving can be time consuming. This is where the elimination method is useful. In order to eliminate an unknown in one equation, we need to make the coefficient of x or y the same size but opposite in sign. Like the coefficients to y are in these equations, the top equation, the coefficient to y is -5, and the bottom equation is +5. Then we would add the coefficients and the constants from one equation to the next to eliminate one of the unknowns. This method can be used to solve complex equations with more than two unknowns. For now, we'll just focus on two unknowns. Remember, to solve simultaneous equations, you need the same number of equations as unknowns. If we had 3 equations, we could solve for 3 unknowns. So the elimination method is best used when you have equations in the general form. So the first step for solving is to label the equations and then identify which variable has the same coefficients. One of the unknowns needs to have the same leading coefficient. In this case, they already do because the x's both have the coefficient of 1. If they had a different coefficient, then we'd have to multiply the equations by a suitable number to ensure an unknown had the same leading coefficient. So x has the same leading coefficient. In this case, they're both positive, so we're going to subtract equation 2 from equation 1. So all we're doing here is subtracting 1 from 1, which is the x coefficients, and we're going to subtract 5 from 1, which are the y coefficients. That gives us -4y. And we're going to subtract 11 from 3. We're just doing this vertically or within the columns. Now we can eliminate, we've eliminated x, we can solve for y. So divide by -4, y equals 2. Now we can substitute this back into our original equation and solve for x. And we get x equals 1. Therefore the solution is x equals 1, y equals 2. We had two equations with two unknowns, x and y. The solution x equals 1, y equals 2 gives the values x and y that make both equations correct. Here's another example. So we label the equations. This time the y variable has the same coefficient but opposite sign. Because it's opposite sign, now we add the equations to each other. So first of all, we'll add the x coefficients. So we've got 2 and then 1. We add them together to equals 3x. Now we're adding 3y to add -3, which cancels and gives us 0y. We add -14 to 8, which gives us -6. Now we can solve for x. Get -2. Now we substitute this back into our original equations and we solve for y. So we get 3y equals 12 divided by 3 both sides. We get y equals 4. For the solution to these equations is x equals -2, y equals 4. Here's a more difficult example. You'll notice this time that neither of the unknowns or variables have the same coefficient. So we can make x have the same coefficient if we multiply equation 2 by 2. So that means we multiply every term by 2 within the equation. To show to you that, or to demonstrate that multiplying the equation by 2 doesn't change the equation, I've plotted both of them on the graph here. You'll notice that there's only one line, and that's because they are the same equation, and the lines are on top of each other. That's just to demonstrate that by multiplying the second equation by 2, we haven't changed it at all. So now we've multiplied everything by 2 in the second equation. Because x has the same sign, we need to subtract equation 2 from equation 1. And that will give us 0x equals -7y equals -42. Now x is eliminated, we can solve for y, and that works out nicely. We get y equals to 6 because we're dividing by -7 both sides. Now we can substitute that back into our original equation and solve for x. And we get x equals -4. So the solution to these equations was x equals -4, y equals 6. Here we have a more difficult example. Again, we need to label the equations. Now we've got to get the leading coefficients to one of the equations to be the same. So we're going to multiply equation 1 by 3 and equation 2 by 4. This gives us 15x take 12, y equals -36, and 8x take 12y equals -8. Now you'll notice the coefficients of y are the same. So we have to now subtract equation 2 from equation 1. That leaves us with 7x plus 0, because the y's cancel out, equals -28. Now we can solve for x equals -4. And we substitute that back into our original equation to solve for y. And we get y equals -2. Therefore, the solution to these equations was x equals -4, y equals -2. Thanks, guys.